Hey, third hour. So here's the directions for today. Since you have to watch a video of me or hear my voice and see what happens. Mr. Opal, his goal is to pause the video at any moment in time. One of you guys need the video to be paused. So if that happens, raise your hand, and his goal is to immediately pause the video. Second, I need you to write down everything possible today to the best of your ability, because yesterday I wanted to stress that retakes will depend upon what do your notes look like. So whatever we write down, I need you to write it down also. All right, so the topic, functions, today's date, and the essential question is, how can functions be described? Let's start with the first one, discrete function, the definition. So you have a table on your notes. Discrete function is going to go in the word section. And then the second column says, what is the definition? And let's put down the definition: graph that consists of points that are not connected. So an example of a discrete function looks like disconnected points if I'm looking at it as a graph. Discrete would be some sort of mapping. Ooh, wait a second, not a function. So discrete, there is a set amount of numbers included. And an example of how it could be read is if you think about jersey numbers of a team. The set of jersey numbers is an example of a discrete function. No two people should have the same jersey number. And you also wouldn't see somebody have 2.5 as a jersey number. So going back, next definition word, continuous function, which is a function graphed with a line or smooth curve. So if I want to see what it looks like and reads like, looks like our time versus distance graphs, where it can be connected with a line of some sort. One example of reading about it, time distance graphs are continuous functions since time keeps going and time is continuous. You can look at 5.02 seconds and so many other ways. We could just stop at this graph and see how far have you traveled, or are you taking a rest currently, and so on. So Mr. Opal, I want you to take a moment to pause the video so everybody can read. And what we're going to do is we're going to make a table of values showing this relation between ice sculpting team and the height of their sculpture. So when we do this, team number 1, it looks like they had their ice sculpture at 4 feet. Team number 2 was at 4.5 feet. Team number 3 was at 3.2 feet. Team number 4, 5.1 feet. And team number 5 was at 4.8 feet. So if I look at the domain and range, domain would be all of the team numbers, 1, 2, 3, 4. The range would be all of the heights of the sculptures. And let's put them in order. I just realized I forgot one of the team numbers. Anyway, the ice sculpture team would be in order. Now we're going to write the data as a set of ordered pairs where the team number is going to be the label of the x-axis, and the height of the ice sculpture will be the label of the y-axis. And we're going to pair these up. So the first team built it up to 4 feet. So we're going to put their point as team number 1, 4 feet. Then we're going to go to team number 2 and go up 4.5 feet. So we're sort of in between, and so on. Team number 3, 3.2 feet. Team number 4, 5.1 feet. Team number 5, 4.8 feet. The last question says, okay, is this discrete or continuous, and explain why. And what we're looking at is discrete because they're disconnected. They're not connected with a line, and there's no reason to connect them with a line. It wouldn't make sense since teams are separated. So one way to explain it, it's a discrete function because the points are disconnected. So let's say we have a bird feeder and it holds up to 3 quarts of seed. Feeder weighs 2.3 pounds when empty and 13.4 pounds when full. Let's make a table showing that when it's 0 quarts, 1 quart, 2 quart, 3 quarts of seed in it, it weighs these amount of pounds respectively, meaning when I have no quarts of seed in it, it weighs 2.3 pounds. When I have 1 quart of seed in it, it weighs 6 pounds. When I have 2 quarts of seed in it, it weighs 9.7, and so on. Let's create a table. So when I have no seed in there, it's 2.3 pounds. When I have 1 quart, it's 6. When I have 2 quarts, it's 9.7. When I have 3 quarts, it's 13.4. So let's state the domain and range. Domain in order least to greatest is 0, 1, 2, 3. Range in least to greatest 2.3, 6, 9.7, and 13.4. Now we're going to write the data as a set of ordered pairs and graph the data. I just realized I did not write the data as a set of ordered pairs on the previous example, so we're going to do that now. So writing them as an ordered pairs, and we're going to have the number of quarts of seed for the x-axis, and then the weight in pounds will be our y-axis. So when we have no quarts, we're at 2.3-ish. 1 quart, 6 pounds. 2 quarts, 9.7 pounds. 3 quarts, 13.4 pounds. And would it make sense to connect them? Since over time, the number of quarts, like you can fill this in, it will make sense to connect them with a line. Because we could have half a quart inside that bird feeder, or we could have 1/3 of a quart inside the bird feeder, or a fourth quart, and so on. So for the last answer, do we have a discrete or continuous function? This is an example of a continuous function. So in a roundabout way, I said, yeah, it's a continuous function because we can have half a quart and 1.3 quarts. It makes sense that we can connect those points with a line because over time, that seed gradually fills it up. Okay, Mr. Opal, if you could, please pass out the following worksheet and pause this. I want to make sure we're all on the same page of how to do problem 1. So, if Christina earns $7.50 an hour babysitting, and we're supposed to write an algebraic expression to represent the money Christina will earn if she works so many hours. Let's think about this. If she works, we might have to do B first. This is something we did not cover in class. But let's say, okay, we're going to choose a number of hours and then compare it to the amount of money. If she works no hours, she gets no money. If she works 1 hour, she gets $7.50. If she works 2 hours, well, $7.50 and another $7.50, you're at $15. If she works 3 hours, well, so $15 and $7.50, you're at $22.50. If she works 4 hours, well, $22.50 and another $7.50, $30. So it says choose 5 values. I think we have our 5 values. So what could we do every single time to jump from the number of hours to the money? And we could multiply number of hours by $7.50. So what that looks like as an equation, because it says write an algebraic expression, what that would be is, okay, take $7.50 times the number of hours, and that's going to give you the money, which is what we used in our table. Now, I feel confident you're going to be able to create a graph. Now, our x-axis is going to be the number of hours. This is the independent variable. Well, we don't have really a lot of control over, or depending on the number of hours, depends on how much money she gets. So if she doesn't work any hours, she doesn't get any money. If she works 1 hour, she gets $7.50. If she works 2 hours, we're at $7.15. 3 hours, $22.50. 4 hours, $30. So the question is, does it make sense to connect your graph, to connect the points? So let me ask it a different way. Would it make sense to ask, can she work an hour and a half? Could she work 2.5 hours or 3 1/3 hours when you babysit? And here's where it becomes a little, a little difficult, because depending on who you're working for depends on whether they're just going to round up to the next hour and give you that amount, or whether or not they're actually going to be like, okay, you worked half an hour, so that's splitting $7.50 by 2. I'm going to say, I'm going to be a nice, or you could say I'm mean. Either way, I'm going to say that this is continuous, because we can split up an hour in half. So I'm going to say it's continuous, because we can split an hour into fourths, like 1/4 past an hour and so on. All right, so let's go on to the next one. All right, on the next one, it costs Cole $3 into the volleyball game. Popcorn costs $1.50 per bag. Cole loves popcorns. Now he eat multiple bags in a night. Write an algebraic expression to represent the total amount of money Cole will spend at the game if he eats P number of popcorn. So let's think about this. Every bag of popcorn costs $1.50. So $1.50 times the, however many bags he wants to eat. But you also got to get into the game. So that's $3 more. Well, that's going to equal how much money he's going to have to bring to the game. So let's do this table together. You've got the bags of popcorn and the total amount of money. Let's say he doesn't eat any bags of money. Then all he's going to spend is $3. Let's say he gets 1 bag of popcorn. If he gets 1 bag of popcorn, that's $1.50 plus getting into the joint, that's $4.50. He buys 2 bags of popcorn. Well, 2 bags of popcorn is $3 plus the $3 to get into the joint, $6. If he gets 3 bags of popcorn, so 3 bags of popcorn, that is $4.50. My mind. $4.50 plus another $3 is $7.50. If you have 4 bags of popcorn, that's $6 just to give to the concession stand, and we end up with $9 after that. So let's go to the graph. Let's go to the graph, and we're going to make sure you label your axes. Let's put the dependent variable as number of bags of popcorn. And the y-axis as the cost in dollars. So if we don't buy any bags, we owe $3 and so on. Go ahead and pause it, let them plot and discuss. So after you plot, we've got to figure out, does it make sense to have this be discrete or continuous? Can you have, so the question is, yeah, I can have half a bag of popcorn, but the bad thing is the concession stand won't let me just purchase half a bag of popcorn. They only give you one bag of popcorn. You can't get a fraction of a bag and the concession stand not charge you for a full bag. So this graph would be discrete because we can't get, or we can't buy half a bag of popcorn. We're still going to get charged that $1.50. I want you to try, either on your own or with Mr. Opal and Miss Myerscough, the last two problems. See if you can develop some of these equations or come up with them together. It's whatever you guys choose as a class. I don't care if you do it all together or what, but let's get it done.